Hello, my name is Chris Pisani, and this is my data visualization project. So, the data that I decided to go with was a lifestyle dataset that I found on Kaggle. And with that dataset, I threw together a couple of different business goals. So, after looking through a lot of the stuff that was available for this dataset, I realized that this data would be really good for analyzing lifestyle and fitness data to determine a couple of different factors, those being workout performance, health metrics, and nutritional habits. I wanted to identify the trends that could be created across this data set and produce visualizations that highlight the key insights. And off of that, I wanted to use the findings to inform personalized fitness and dietary recommendations to anybody that was using the visualizations that I'm going to show you. So, off the business goals, I came up with a couple of different questions that I thought were important to answer. Those being, how does age and experience level affect workout outcomes like calories burned, heart rate, and BMI? What is the relationship between types and durations of workouts with calories burned and average heart rate? How do dietary habits correlate with body composition indicators such as fat percentage and BMI? And finally, which exercises and workouts provide the greatest calorie burn and health benefits across different difficulty levels and targeted muscle groups? These are a couple of pretty general health related questions that can be answered through a wide variety of data. So I took these questions and I broke them down further into even more specific queries that could be highlighted through visualizations. That came out to be these 8 questions being, how do average calories burned vary across different age groups? How does experience level influence calories burned per workout session? How does session duration impact calorie burn for different workout types? Which workout types produce the highest calorie burn? Which nutrient ratios are most associated with healthier BMI levels? How do macronutrient intakes relate to BMI and fat percentage? Which exercises yield the highest calories? And which exercise categories offer the best calorie burn? So I wanted to design multiple visualizations that could answer all of these questions, and this is what I came up with. The first one being a bar chart. You can see a preview of it on the right. And this bar chart aims to answer 2 of the questions, those 2 being, I believe, the top 2 in the previous slide being, how do average calories burned vary across different age groups, and how does experience level influence calories burned per workout session? So we can answer the first question, how do average calories burned vary, by looking at the chart and seeing that the average calories consumed, this can also be switched on the y-axis between calories consumed and calories burned to be associated with age and experience levels. So you can see across all of the different ages and the experience levels in the legend that it varies depending on experience level. So someone that might be less experienced will burn a little bit less calories during a workout session than somebody else, and you can use that to make an informed decision. Similarly, with the second question, how does experience level influence calories burned per workout session? We can see on the right we have a legend for advanced, beginner, and intermediate, and we can see that there is a difference between each of the 3 in the different age groups and the amount of calories burned slash consumed for that. For the second visualization, I have a line chart, and this answers a couple more of the questions. The first one being, how does session duration impact calorie burn for different workout types? So session duration impacts calorie burn. Obviously, the longer a session goes on, the more calories you're going to burn. So you see as the duration series forward from 1 to 2 hours or so, it goes up for all of them. But you see a very common trend between all 4 of the different workout types, and that being that the HIIT which is a high intensity workout, is always at the top, and that yoga is always at the bottom, and that everything kind of keeps its place with the calorie burn over duration. And which workout types produce the highest calorie burn is it's still the high intensity one. That hasn't really changed across any of the data. And which exercise yield the highest calories? So you can't see it in this view, but if you switch the y-axis to be calories consumed, you can get a better answer for that. And which exercise categories offer the best calorie burn? You can also see that that it's ordered the way that it is, with HIIT being at the top, and strength, cardio, and then yoga being followed. Lastly, I created a scatter plot, and this showed a rather unique ratio of something that I created, a carb-protein ratio. So this is the amount of carbohydrates that someone consumes in relation to the number of proteins in grams that one might consume. So if someone's eating 100 grams of carbs and they are eating 20 grams of protein, they would have a carb-protein ratio of like 1 to 1.2 or something like that, 0.2. And the questions that we have for this in relation to it are: which nutrient ratios are most associated with healthier BMI levels? So the nutrient ratios would be the carb-protein ratio, and how that associates with a healthier BMI level. So it looks like there's actually a positive trend, just looking at the overall data set. Each one of these bubbles represents one of the nodes in the data, so this represents all of the data. So we can see that people that have a higher carb protein ratio are more likely to be have a higher body mass index. And how do macronutrient intakes relate to BMI and fat percentage? We can also see that here with the carb protein ratio and body mass index. So those are just some previews, but we're going to go into the actual data itself and the data source that I gathered it from. So I found this data set on Kaggle. It is called the lifestyle data. It came up on the site about a month or two ago, I think, and the reason that I chose it is for two different reasons. One is that the data set itself is very comprehensive. You can see as I'm scrolling through this that there's like over 60 different variables that you can use, and there's no null data values. So there's a lot of stuff to work with. And the actual data set itself is 10 megabytes, and it contains, I think, about 25,000 entries. So I was hoping with the various amounts of columns that were provided and the amount of data that I could find some cool trends that could be discovered with a couple different visualizations and their filters themselves. So now we can actually get into my visualization itself and give that a brief overview. In the top left here, I have a workout type filter. So the 4 different types of workouts that were provided in the data were cardio, HIIT, strength, and yoga. And when you click any of these, it'll actually filter the data depending on what you're clicking. So the bar chart, the line chart, and the scatter plot are all affected every time you click any of these. And that's actually true for all of the legends and any of the things that are interactive on this as well. So for instance, if we were to select advanced on the bar chart, you see that the line chart and the scatter plot are also affected adversely. Or if you were to, for instance, select a age, you can see all of the data here is only for people that are age 37. And conversely, if you were to select the workout type in here, it has a similar effect to selecting in the top left, but it doesn't actually remove the data in the line chart, so you can actually still see it. And then for the bar chart and the line chart, you can switch the y-axis to between calories burned per day and calories consumed per day. So you can kind of see a ratio between these and see if you can see any comparisons or see any trends with data with certain filters here. So I'm just going to go through some different use case scenarios, or just go through some general like filtering of ways that you can use the data. So let's say that you are a 29-year-old individual and you wanted to know what you would expect to burn for your age range and your experience level. So if we switch this back to calories burned per hour and then we select age 29, we can see that there is these data here, and if you hover over them, you can see that calories burned per hour is 929. That is the average for this age group. If you are a beginner, 1042 for an intermediate, and 1129 for an advanced. So you can see as the experience level goes up, the calories burned per hour goes up as well. And you can see that that trend actually follows for most of the other age groups as well. It's kind of hard to see with the stacked chart, but the usefulness of it is that it's very easy to tell when you mouse over it. And then let's say we want to say I am a beginner. So if we just select beginner here, we can see all of the data related to being a beginner on the charts, which is pretty nice. And we can swap that over to be calories consumed as well if we want to look at that. And with that, we can do something similar where we want to look at, let's go to age 29. Actually, let's go to age 31. And we can confirm that, get our data here. And then we have this. So you see for a beginner that is age 31, you see 1531, 1975, and 1870. So experienced actually isn't at the top for this one. And then we can filter it further by, let's filter it by intermediate. So that only shows intermediate. And then you see all of the other data changing on the line chart and the scatter plot as well. So someone consuming 1975 calories per day, you can see all of the people that are age 31 that are participating in this, and the average calories that they would burn and the different types of workouts that they're doing. So common trend that you'll see is that these usually stay the same with the workout types and the calories burned. When you get into calories consumed per day, you start seeing different trends where people that are at certain workout sessions are eating different calories amounts. For this is the amount of hours of workout that they would do a day, and it's not as much as a definitive trend as the other view, mostly because someone that is burning more calories doesn't necessarily mean that they're eating more calories if they are trying to lose weight or are more fit. So let's just reset the view and do something else. So let's work with the scatter plot now. Let's change this back to average calories per burned. And then let's use the filter here to filter by strength. So now this is just individuals that only do strength training and nothing else. You can use that strength training, and then you can say, I want people that do strength training that only work out 2 days per week. And you can say, okay, let's say I'm a 25-year-old individual, and I'm a beginner. Let's change this back to calories burned. Say you're a 25-year-old individual and you're a beginner. You can expect to burn about 990 calories per hour doing strength training, doing with these filters, and you can see that the average calorie burned in an hour here is pretty similar. It's about 990 because these charts should line up. But if we switch this to calories consumed per day, you can see at the 1 hour mark that someone's consuming about 2,000 calories, which is about on average for training. And you can see all of the different data points for people that have this stuff here on the thing. So if you mouse over this, you can see little clusters here, and you can see that people that strength train for 2 days a week and are beginners are pretty clustered around the average. I think the average BMI is between 15 and 25. So those people tend to be more on the normal side for following these trends. Yeah, let's do one more. So let's go with the scatter plot. Let's say that you are looking to slim down a little bit and you want to know what is the best amount of workout days per week to do if you want to reduce your body mass index, and what carb protein ratio should you expect to kind of fall into if you want to hit that. So if we go through these and we just filter, so let's do 2. So you can see that if you do 2 workout days per week, it's pretty varied. There's a large cluster in the normalized range, but there is also a lot in the other as well. So if we go to 3 days a week, you see something actually pretty similar. It's about the same. Then if you go to 4 days a week, it's also pretty similar. So there's not really any correlation between 2, 3, and 4 days a week and its effect on body mass index, according to this, or carb protein ratio. But if you go to 5 workout days per week, you actually see something different. So you see that there is a large cluster in the 20 to 30 range, which is a lot different than the other ones. So you can say, okay, I am a 30-year-old individual, and I want to work out 5 days per week. Where do those people usually fall on the chart? And how often do they usually work out? Let's say they want to do strength training. So you can see all of that shit. You can all of that stuff. You can see that there's a couple different data points that actually fall into this. So you can say, I want to be a strength trainer that works out 5 days a week, and I'm 30 years old. What could I expect my carb protein ratio and body mass index to be if I were to pick up this diet regimen? And you can see that there's a couple data points, and you see these people are actually in the pretty normal range, 22.3 to 22.55. Oh, I see one down here. It's 22.65. So that's not bad. That's pretty good. If you were to say like someone that, let's clear this off, that only works out 2 days per week and they're 55 years old, and they only do yoga, which is the lowest of the calorie burning things. So what we actually see here in the data is that you either have a very low BMI and carb protein ratio, or you have a little bit on the um, average side with one outlier over here that has a BMI of 40.8 and eats a lot more carbs than proteins, it looks like. Um, so it's actually pretty useful for like seeing like if you were to um, model out a potential workout scenario for yourself for planning for the future, to seeing what sort of people sort of fall into these ranges when you um, do this sort of data. So let's clear this up. So yeah, we have all of this different data, and it all works coherently to sort of show you what you want to see. It's pretty lenient with giving you the answers that you want as long as you mess around with it. At a baseline level, the bar chart doesn't really seem to show like any um, clear trends with like age or experience. But you can see minor trends um, in the duration and body mass index charts to sort of see like positive trends and where you want to fall on those. But yeah, I hope that this was pretty interesting for you and that this was um, something well done. And thank you. This was Chris Pisani, and thanks for listening to my presentation.